idea as per the Mines initiation. So these economists who prepared this based on all the input received from industry and everything. So the presentation is what I want to just read it. So first going back, how many people understand the difference between resource and reserves? If you do not know, please say no. But if you know somebody, I would like them to answer this question. Resource and reserves. Nobody knows?
Sir, resource is when we have drilled up to G2 level, so we call it a resource. It is of three categories. Then
When you definition of resource, don't bring G2, G3. It's an independent
and
one.
the resource which is mineable, which is based on economic and feasibility criteria, and can be mined out. So that goes to reserve. Rest is resource.
What is resource then?
Resource is mineral present in our area which has been explored. That is resource.
See, resource is the one which has got some value, but does not have the full geographical understanding. Whether the length or breadth of this thing and quality is also vague. So there is in situ material is there. It has got some value, but we are not clear about the quality or quantity. So it is a material which is lying in space without this any of attribute related to quality or quantity or the dimension. And whether it is fully discovered or identified also is not clear. So that is what is resource. And from there, resource, you go further detail, deep dive what they call it, get into the detail and find out what is this material, how do I define this material when either sampling or by drilling to define the boundary of the work, and then is it, what is the quality depending upon the type of mineral, and whether it is economically extractable. Only then, what is economically extractable, meeting your quality, meeting your feasibility to mine, all these parameters adds to get into the resource. Okay? So that is a major difference. Now coming to G1, G2, G3, we will explain as we go further. Go to the next one. So this is even terminology. Go ahead, please. See, before this, then people say that 1994 ENSC means what happened before. Before also there was a classification which is called BI standard. Indian standard classification, what we call, we used to call ore mineral resource. Go to the next. Proved. So this was classified under three categories: proved, probable, and possible. Proved means fully established. Probable means there is a limitation. Possible, likely to happen. And this is last one is perspective. This is what we now call it as in between the inferred and the reconnaissance one, the conditional. So various technologies were there, already there in place, but to make it standardized, then it can. Next one. So here it talks about various countries. You can just run through one. So we will not get into this because we are right now, as a geologist of India, you should first understand the intricacies of UNSC. After that, you can go to job, all the other things. Go ahead next. This talks about the general. Then USGS, United States. They have their own terminology. Europe, they have their own terminology. Each of them they have. Then China have USGS, Western have. Then next. After China. Now, mineral resource classification by agencies. You know, there are these are USGS, United States, United Economic Council. DSI brought out a report on the standardization of terminology and classification of mineral resource in publication 81. Then UNSC, this was adopted in 1997 after a long deliberation of the 40 countries. Next. This is a framework, that is what United Nations framework classification. And this is the first terminology in interview also people ask me. What do you mean by UNSC? Full form is United Nations Framework Classification. This has been developed by the Economic Commission of UNEC based on this thing has come. Okay? So where it applies, the main objective of UN Framework Classification is to create an instrument that will formulate reserve and resource of solid fuels and mineral commodities. So here oil is not included. That has got their own classification. Okay? Next. So when this was brought in, then we already got certain classification. How do we transfer that data into this format? Is a lot of deliberation also. This is a new classification designed to allow incorporation of existing terms into in order to take the comparable, compatible, thus enhancing the international. Purpose of this was to have a common platform so that every country talks the same language. But because of the standards what they apply, still there is a what we follow as per the UNSC classification, we are the bottommost. Then you have got a job which is like better than this, NI 133, NI 43 that is still higher than that. Then latest is what ArcelorMittal insisting for getting it done for the report using this thing. SEC, economic regulation. Yeah. So their standard is still higher than that. So this is all depending upon the company where it is registered and where it is reporting in stock exchange, because in India, in stock exchange, we don't give much weightage to the mining industry. So whatever report or anything, it goes like this. Whereas in foreign company, they are very, very clear. Because you are raising money through a stock exchange, so your number, what you are putting should be fully authenticated, should be substantiated, and that should be as per international standard. In case of any violation, there are lot of this thing, breach of privilege, the criminal cases, and people have also been prosecuted and still in jail. So these are the things. So that's very tight about that. India, nobody can. It goes by UNSC, whatever you declare, you declare. But in foreign country, it is not like that. Next. Okay, we go to the next one. So now, as I told you, 1997, 99, and this system is known as UNSC classification adopted. Next one. Yes. So how it started in Indian Journey was 93, 99, 2000 is what? Finally, government put a task force to reporting and guidelines debated in a seminar. The outcome of the guidelines is what we find in a public domain. 2000, which has come. Go to the next one. Now, okay, reference to central state. Yeah, go ahead. These are all events only. Yeah. Now you read this. This is very important. There are three important parameters in this. Anybody can, which are the three critical parameters listed out in this? I want answers. At least read that and understand. What are the three critical guiding factors it is going to drive? What is that?
One is geological axis, second is feasibility axis, and third is economic axis.
Economic, that's what is listed. Geological certainty, feasibility, and economic viability. Because you may talk geologically, it's wonderful to say that 1 gram of million ton.
Yes.
But end of the day, is it feasible to mine or is economically viable to develop a mine? These two also should be in sync with the terminology. Then only it becomes a mine. Otherwise, it remains as a resource. It cannot be taken as a reserve. Next. So here we are talking about three. So easy to remember this is E, F, G. You have to go reverse there. E, alphabetical word, E, F, G. These three axes you can't forget because it goes alphabetically. E is economic, F is feasible, G is geological. Okay, go to the next. Yeah, now if you look at economic. So this economics also it is divided into three subcategories. One is economic, then potentially economic, integrally economic, intrinsic economic. Now if you see 1, 2, 3, what does this word 1, 2, 3 indicate? Which is the topmost, which is the bottommost in this? You got three sub-classification of economic axis. E, economic axis is divided into three. E1, which is E is economic 1, then potentially economic it is 2, then integrally economic 3. So if you look at 1, 2, 3, according to your what is shown there, which one you find it is the topmost, which is a very high level, which is the bottom level? Anybody can tell? It has to come quickly, yeah. Which is the bottommost?
Diagram.
come open. Don't try to say that either one or the
Bottom
other.
is weak. The bottom
I
is
think
weak.
problem with you is don't even listen. Did I talk to geology? I am talking about economic. Yeah, I am talking in economic. There are economic 1, it is written, potentially economic 2, then intrinsically economic 3. So my question to you people is 1, 2, 3 is written, which is the most superior, and if you put it in a slang language, which is the most inferior between these three categorizations. Which number qualifies inferior, which number qualifies superior?
One is superior.
Why? Why? Because it's
more economic. It provides more economic than the
Yeah,
other
so
side.
that is the wording itself. Please read that. Don't get into the detail. You can read that. One is economic. Not what we are talking. Economically, it's viable. Potential. What do you mean by word potential in English? You can. Many of you, if you understood that word meaning.
So potential means it has ability but can't show it.
Likely to happen. So that itself indicates may or may not. That's why it's slightly little lower. Then intrinsically economic. So it is going to the extreme end. Unlikely to happen also. So that is the reason it is on 3. So this is talking about the economic axis. We will not go very detailedly here because as a geologist, it's fine to you should know economic and feasibility. The deep dive is in people at this your level. You should be very clear about G axis. But you should also know what is E and F. That's the reason I'm trying. Go to the next one. Sorry, 1 minute.
Yes.
Now if you look at feasibility axis, again it is divided into 1, 2, 3. You read, one of you can read that 1, 2, 3. What is that?
One is feasibility study and mining report. Second is pre-feasibility and third is geological study.
So if again you want to put order of superposition, which is the topmost, which is the bottommost?
1, 2, 3, so one.
Yeah. So it clearly sees bottommost means only study has been carried out. So geological axis, you have done whatever level is required. In the feasibility also the focus has only been on the geology. Whereas the second one is pre-feasibility. Because there are, when you want to see that deposit to go to the next level, in the feasibility study, to make it very whether it is feasibly possible or not, there are other governing factors which has to be taken into the account. So it speaks about that. That is the word pre-feasibility is written. So it is in between. The topmost is feasibility. Oh no, yes, this can be developed into a feasible mind. What are the guiding parameters required to be studied under this category is already been done. That's why it is coming to pre-feasibility. Then pre-feasibility study. Okay, so this is now in the feasibility axis. Now coming to the geological axis. There are 4. Only in geological axis you find it is slightly expanded into 4. 1, 2, 3, 4. Now anybody can tell what is this 1, 2, 3, 4?
Stages of performance.
Yeah. What is it? What do you mean by detail, or let us talk about reconnaissance? What do you mean by detail reconnaissance level?
So it is a large scale like mapping.
Yeah.
Last we mapping to identify the mineral in the
Is
test.
present or likely to be there, or indications are there. So you go to the very level in which it's a purely mapping or reading the desktop studies, understanding the regional picture. Yes, for example, this area, if you are looking in a sedimentary basin, particularly in a limestone terrain, no, I want to see where iron ore is there. It will not. Then it's very clear that that particular sedimentary basin is a or Cretaceous later formed basin. So it is a calcareous zone. In that you cannot build ferrogenous. There could be a small ferrogenous material, but you cannot. So if you can, the targeting itself should be clear in geological axis. When you do reconnaissance, what is that I am looking? What is the geological information which is going to give guidance to that? That is where the reconnaissance comes. Now next it is going to the prospecting. So in the prospecting stage, what you do?
So how much more detailed mapping and with the surface samples of some areas.
Yes, this is what we do that. So whenever any client offers you, okay, I want, for example, want to assess put up a cement plant here, or I want to find out in because steel plant it's other way, it's longer time. Let us take a simple commodity like limestone. When somebody wants to put up a cement plant, they say I'm looking for putting up a cement plant in this location because there is a lot of cement consumption required. Now the next question comes, what is the main raw material for making cement? What is that? So limestone. So now the limestone should be existing in the region. So that important, that is where if the person says, I want to put up exactly the cement plant in Bhubaneswar city, then you cannot, we can tell you that Bhubaneswar, I think it's more of a geologically what it's, I do not know, but you have to move out another 100 kilometers away, then when you find some sedimentary basin. So even Gondwanas are further away. So you can't have it. Then you have to tell him that what is the likely scenario of the sedimentary basin which is holding limestone is surrounding in this region. So that is where we take a reconnaissance visit and indicate to them that if you want a plant to be here, the nearest to possible occurrence of limestone as reported in the literature or as per the geological map available in these are the regions. Now the industrialists who want to put up a cement plant have to take a call. So because of the bulk mineral required, volume of material required, you cannot bring the limestone all the way from there. But now we'll ask that how come steel plant is doing. There is a difference between steel plant and cement plant. Cement plant, the limestone commodity is a bulk. Iron ore is also a bulk commodity. In terms of value, it is quite different. Limestone, roughly you get 1,000 rupees per ton. It's available in the market. Whereas here, iron ore, it is 4,000 or 5,000. Value is bigger. And when you convert the iron into hot metal and then into steel, the value is very high. So it can afford the cost to be taken to a place where, because the other important thing is the movement of the output product everything. Whereas in cement, it is a thing that even in a rural area to put up, every district or every city is expanding, so the consumption is there, it can move. So that is the reason. So we go to the community, the entrepreneur and tell him, okay, reconnaissance fund we have done and indicated to you, let us do some prospecting work. I identify which are the regions which is holding a potential limestone deposit which can meet manufacture of cement. Because every limestone you cannot make cement. The quality of limestone is also equally important. Then availability of such limestone is identified, so that is where we say prospecting. So once that indications are there, now the next factor comes, are we guaranteed, are you sure about that? That is where it gets into the level 3, which we are calling about the general exploration. So there we do. For general exploration when we do, we get a confidence to him, to the entrepreneur telling that we have carried out the drilling, subsurface wise, quality wise, quantity wise, we have seen it can more or less meet the requirement. So that is where you come to the level 3. So when we do this exercise, we clearly get an indication that quantity wise it is meeting, quality wise, broadly it's fine. Now that further detailing is what, because why we are going various stages is, at one go I want to drill entire area by 50 by 50 meter or 100 by 100 meter, huge money you spend. End of the day you land up with a resource which is not substantial, at the same time quality is not meeting requirement. By spending huge money you are wasted. So in order to minimize the risk, you go from 4, then you get into 3, then get into 2, get into 1. So that this money is also saved, at the same time you minimize the risk for the entrepreneur when you go to each level of that. Now how it is done, everything will go to the next level. So on the right hand side you can see the axis how it is written. Left hand side you can see the feasibility, then the right hand side you can see the geological, and from the bottom to the top when it goes economic. Topmost, everything should converge into one. That is ideal situation where economic wise it is one, category 1, feasible wise it is 1, and geological axis wise 1. So all the three when they converge, that is the ideal situation where it can be developed into a mind to go to the, it has reached all the basic requirement of economic category, feasibility part as well as geological side. Go to the next one. So this is what axis, geological axis, feasibility, economic, register, reconnaissance. Now the wording, reconnaissance is where they talk about G4. Nowadays nobody talks about reconnaissance or prospecting or general or detail, they talk about G4, G3, G2. Then you should not ask somebody, sir, what is the G4 of the law? So immediately you should recollect. G4 means reconnaissance. If it is G3, prospecting. G2 is general, detail. So now you tell what is that, based on what all knowledge you have got, where does Thakurani stand, whether it is Thakurani or Sagasai, which level of work has been done so far? G1 I will not say, G2 level, whereas Thakurani has been done, but we have got lot of issues involved in that.
So currently we are working in G1.
See, working is, there are two things. The question is, and if you go by the norms, 100 meters, the borers are built, it's on G1. But look at the quality specifications required, because the end product is very, very sensitive to various parameters. To that extent, possibly based on the structure and the complication that the deposit has got, the G1 also may not be that 100 meters. So we go 50 by 50 meters also we do that. So here we have to differentiate between what is the compliance required as per the government regulation, this G4, G3, G2, G1. The spacings are also like this. If you look at this prospecting stage, reconnaissance level, there is no drilling. It is purely surface examination, nala cutting, or river bed you have to do. All the thing, or possibly you can look at adjoining area, what is happening. So if you have got a limestone break, if you have got a limestone, in between is this area. So you know that by connecting, suddenly unless until there was a big fault, the whole limestone deposit should continue. So you can find the continuity of it. We can take a guesswork and see that G4. But when it comes to prospecting stage, because of horizontal nature of deposit, they are defining the spilling, drilling, spacing should be at 400 meters. When it comes to the general, they say 200. When they come to detail, it is 100 meters.
So picking dredging in
It comes under reconnaissance. Reconnaissance only it should be, but there are, depending upon the commodity, suppose this is like clay. You cannot go to that level of detailing because it itself is an isolated body. There are some chromite, body from chromite deposit, which is also like that. If it is very thin band and it is very lensoidal in shape, don't require such a thing, so the pitting and drenching will do. So it has also to go by, but right now we are discussing about one commodity in volume. But so to that extent we are looking at, and it's a tabular linear body, continuous deposit, that is there. For each of them they are given a guideline. But this guidelines, what spacing it has to be done, what is existing from India. Foreign they don't follow this. They say it is left to the geologist to identify what spacing is required to define the continuity of the body. Even at 400 meters, if the geologist is very confident, because it is horizontally bedded, there is no variation which you can see in the observed, because in the bulk commodity it is outcropping. Even at 400 meters, we can certify and give it under a group category topmost. So don't get confused between the spacing of zircon, what is defined in the Indian context with the foreign part. So if you say about JOT, this is what spacing is required, people will laugh. JOT doesn't define what spacing is required to be done. It is the knowledge of the geologist, and the responsibility lies with the geologist in certifying the report also as JOT. That is where the competency is knowledge, skill, experience, based on which is given a certification. So that's why you call JOT certified person. So you have to qualify for that, and you also take the responsibility. Tomorrow if somebody challenges and if you are not able to defend, then one. The registration also could be low. So this is what G4, G3 I told you, the level of this. Okay? Clear? Up to this, any doubt? Go to the next one. So the exact meaning what I was trying to convey it is given. You people can read this. here it gives you broadly the terminology, what is the you need to collect and what is the input you can think of to qualify under this. It is more of a guesswork based on the knowledge, data available, analogies used, and a similar characteristic because as I told you, if you are visiting an area where you have got a mind which is either side of that or one side is there, you know that things may change. The concentration of the whole body may change, quality may be also changing, but the continuity extent is likely to be there, thickness may vary again. So there is a broad input available. So based on that, you make a guesswork. Taking it upon this, we call it. Sometimes we use, in the normal terminology, we use potential tonnage. We don't use a reconnaissance resource, even people call it. So what you are qualifying is based on the parameters which is available in the field, based on what your ground validation you have done, you have come out with this input and we are assuming this based on which you have come out with the input. Go to the next one. Now this is the G3 level. What does it say? Read that. So when you come under G3 part, depending upon the commodity what you are looking, you have to be clear. If you are, for example, limestone, if you are looking, maximum it is mapping is done already in the G4 level itself. Further, major part is any nala cutting, river cutting is visible or natural cutting or the adjoining quarry. All that, all that such data is also still you are not able to get through. At least based on the strike and dim, we should identify a target for drilling broadly to get where exactly to drill, what succession you are likely to get into this. Okay, वो समोसा मंगा सकता है Okay. So now for example iron ore, you find always a laterite cover. So we are not sure below the laterite cover whether you are going to get. Now the question comes is on adjoining mines. So a lot of exploration have been done. Then you find the succession is clear. You find laterite, after laterite cover, then you find possibilities of the weathered portion of luminitic material or something. After that you find a hard ore, then followed by a blue dust or a soft ore, then the blue dust, and finally sometimes the shell or major part is the BHP. So the local succession is known. Whether in your area you are going to get it or not, we do not know. So that is a level of at least for such this thing. One or two borers if we drill in that area. What we call this four borers is at G3 level is mainly a targeted this thing stratigraphic boron they call it. Foreigners all call it as a stratigraphy because they want to establish the full stratigraphy, not the regional stratigraphy. Within that region, okay, if you know, in this region we know very clearly the bottom marker horizon for iron ore is which one? What is the marker? Is only BHT or is there any other thing? Yeah. So now we'll have to really look, okay, shale and BH2 are my marker or reason for that. So in the stratigraphy hole when I drill, you get shale. Then possibly you have to make sure that whether this is typically a shale or it's only a intervening shale, after which there are some enrichment, then you get ore, after that you get BH2. So most ideally we should target to at least one or two boron drill to get the bottom BH2. So that is where we call stratigraphy hole. In the scout boron, to get the picture based on the total area available with a minimum with this thing. So on the placing of the boron, your geological input is very, very important. Just now it's 1 square kilometer, okay. 4 corners, 4 boron, no, that is not the criteria. Placing need not be defined exactly what it is required. It is more of geological structure what is available or the geological formation what is exposed where you want to be. That is one. Second important thing is it horizontally bedded or steeply dipping? If it is steeply dipping, still you are trying to do a vertical borrow. Again, you may land up in the same bed. So the linear variation of quality may not be there because you are drilling through the same bed. If it is very steeply dipping and you are drilling at a vertical borrow, you are very close to that. It may not. But normally here you don't get such a steepness. You get a gentle 30 to 40 degrees. Fine. But if it is more and steeper, we should drill angular borrow. Now the question comes next is, where do you drill this angular borrow? In a normal steeply dipping bed. Anybody can tell? Yeah, that is more important. First is, when it's steeply dipping, identify the local strike, then find out which dip and take some measurement of dip wherever is available. Then average it out, you can find it is around 60 degrees. Then we have to drill across the dip, angular borrow, and that also should be, you should not drill at 45 degrees. So drill at 55 or 60 degrees. Purpose is, in a shorter distance you are getting the total thickness of the ore body intersection, the top and the actual ore and the bottom. So this is where raising of the boron in G3 is not simple. Drill 4 boron you get geological mapping, geological structure and regional picture also you should keep it in mind. And the adjoining mines, if there is any working mine in the area where you can get at least visit or look from the far away, whatever the information available you should get it.
So what is the distance between one and first and second boron?
That is, there is no specific, here they talk about 400 meters, UNSC classification. You should maintain that, but no hard and fast rule if it is 300 also. Some places even if you say that because of friction, I am drilling 200 meters also fine. Broadly you should define and give a justification. Go to the next one. So this is going to the next level. So once you are done G3, so you have defined that area, broadly you have demarcated the ore body, what is top, what is bottom, where I should drill. So then you refine your entire area, divide into further section, maintain the 200 meter spacing, then propose the boron. But as you propose the boron, after the outcome of the boron, for conceptual section you should create. Conceptual section is prepare based on the geological mapping section, like what we have done. We know the proposed boron is this, depth is this. So as we monitor the drilling, we have to go and see. There could be variation happening. So on the surface, whatever gentle dip you have taken to be steep or very gentle, based on this, the contact between the ore and the waste or the marker horizon or the top, things may vary. So to that extent, this is a dynamic one, we should go and change it. We should not fix this or entire section and drill like this. So to that extent, you should always think. So that is the reason what is happening. So here also we find because of the folding nature, suddenly one boron into BH2, other boron is very steep. Then, so some of the boron we have gone through the BH2 set and we have found in some of the boron after BH2 also we got more. So to that extent such deep boron was extended. Sometimes the entire two boron was in BH2. So there could be chance we have to go deeper. But here it's a commercial organization where we cannot aim to go and find out what is happening. We have to have a trade-off between what is scientifically required and what is the minimum exploration we can do. End of the day, I need to identify resources. Geologically, I want to prove what has happened structurally. We can go and do later. That is the initial part. The focus should be on this. Okay. This. So from G3 level, when you come to G2 level, what is your thing increasing?
Decay of the decay.
What is that? In a simple word, if somebody has to put it, what is that it is giving? Confidence level. Confidence means it is accuracy level, and then you are nearing somewhat from G3 you have come to G2, you are better off. Now we go to the next one, G1. So this is where the detail. So one, it will give the highest confidence, defining the ore, everything. And also the second is equally important. Particularly in some of the material, we have to get, for example, in iron ore, we are looking that we have got a shelly ore which is invariably around 50 to 55%. We have got a laminated and other ore fine. This material is so huge quantity you are getting, and it is overlying the iron ore, the hard laminated or soft laminated. So invariably you have to remove this shelly ore. Then you have to stack it because it is above the threshold of 45. Now there are then opportunity which can make use of the exploratory bore or what is coming, but material you have to take it out and do the rapid test of beneficiation. Then detail, like I think one or two for the new deposit, they are given very simple, depending upon this crushing, grinding, some magnetic. So it is paramagnetic, sometimes it picks up some other particle, it segregates. Otherwise rapidly you do that. The 10 mm fraction you take it out, it is slightly better. Between 0 to 10 mm fraction, you subject it to rotation after final grinding, then you find the clay particle going out, there is some improvement. So some of the studies what is required will be made use in this, in the detail this. Next. So far we are dead only on the geological side. G4, G3, G2, G1. Now it comes, the geological axis is done. Now we are coming to feasibility axis. This in all GSI or state government, they restrict only to the geological axis. They don't touch this area because they do not have capability, they do not understand also. Both these things are there. So now when the blocks are coming for auction, he said, geologically I have done. Feasibility and the economic part, you work it out. That is what we do at BMS. To find out what is feasible, whether economics, using the model, create quickly, and if I do this much of production I want to take, what is the minimum waste product I can handle, we should handle, what is the maximum ore I can take. So that strip ratio, because there is a cost involved in that, and how the pit will appear. So based on that, what is the total volume of material I can buy, then apply a cost factor to that. So we do the feasibility and economic analysis parallelly. So this it talks about the feasibility. So you can read this. So you have taken the engineering part is there, in this environment will come, legally is there any issues involved, and the economic part, all that covers in there. Then end of the day, whatever cost part you are putting, the 10% is very important. The feasibility, if you are giving that much confidence, so you have to build in a cushion of 10% the building, so they are very closer to the actual feasible exercise what they can carry. Provided your cost parameters, what you have done is precise. Otherwise, this also is not important. Next. So, what are the things covered in that? The geological part we have been studying. Mining, methods of mining, recovery, manpower required. What method of mining you do? Drilling, blasting is a common. So, in that, are you going to, for example, at Cochrane, we don't have to go on do blasting everywhere. Major hard ore where it is coming, based on that. So the costing also should address that. It may not be blasting USA technique into what it is. Then environmental cost will be there. What is that? Fine dust you are going to generate, or if you are going to have some dry beneficiation plant to recover better quality, what is this line which is going to get? Where you are going to see what impact it has got. And then the plant, the beneficiation part. To improve the quality, what you are going to do. End of the day, the reject what you are going to get has to be right. So anybody knows what is the when you say threshold value for iron? What is it? And what is the number?
45%.
space economy? No. The word, don't, 45 is a number. Is you mean to say anything above 45, it's everything is economic? Yeah. So 45 is a threshold, it is a limit they are fixed. Below which, based on even taking it upon a long term, that above 45% of material may be used immediately or may not be usable everything. It can be stacked and there could be ways and means to improve in the future. So to that extent they said okay. So anything below 45 is what they call reject and above 45 is what that's the threshold value. Then the next category comes. What is the next one? 45 to? Now what is that they call? They call technically if you use the IBM terminology, it is called mineral reject. But then somebody will question that when you are calling mineral reject, why are you stacking? Why don't you throw? No, that is the reason. As I told you, 45 to 55, as of now it may not make much economic sense to recover full value of iron, but there are a lot of R&D work going on. So as of now, easily we can say, improve a mass scale if you do around 50% is fine, depending upon the ore characteristic. If you keep 50 or at least 51%, at least 51% of material, with any the grade 45 to 55, average of 51% of material if you are feeding using different beneficiation process, you can recover around 60%, whose value will be plus 62 to 63% Fe. But there will be 40% of material which cannot be used, which gets generated. So at 60% it may not make economic sense. That is the reason still it is debatable, it's going on. So till that time government has said okay, 45 to 55 you call it as a mineral reject, that has to be stacked separately in your mind, and then it has to be every year what is the material stacking, there is a register you have to maintain, take out sample, quality, everything should be documented. So at the end of the month you get this number, what is happening. Okay? Now go to the next one. 1 minute, go back. So environment, processing, all the four. In the feasibility, you have to check all this. Next. So then all these things are coming. Now cost. Complete कर दिया. खत्म करने के बाद कभी बढ़ते हैं. ये क्या होता है? जलेबी. अच्छी पेपर प्लेट करके हाथ में जलेबी से सबका बात. पेपर प्लेट नहीं होगा ना? तो मंगा लो. या तो ठंडा हो जाएगा.
पर आंटी को बोलिएगा पेपर प्लेट दे देंगे.
सही.
मुझे पता है ना.
So you get into what are the things feasibility further costing, capital, marketing, because if this is a standalone mineral or you are going to use it as a capital use for making steel, that would be a different way of working. Cash flow, so all the factors get into this. So these are all little above your head, so let us not go into the detail, but what is covered it is shown. Go to the next. Now comes economic. End of the day, it has to be, because quality might be good, it is also feasible. End of the day, it should, because the cost what you are going to incur to take out a product, you should be able to make money out of that. If you can't make economic sense, then you are going on spending money, end of the day, it is going to eat away your money. You will not get back anything. So that economics piece. So invariably means that the results in economics are considered to be exploitable at a profit and at existing. So you know lot of things, what are the things you have to, not only today, you have to think of next 20 to 30 years. What are the scenario for that? Okay, meaningful product value. Okay, next. So economic viability, detailed geological knowledge, methods of investigation, mining reports, plan, resource as per specific end use grade. So end of the day, if you are merchant mining, when you say merchant mining and captive mining, what is the difference? Anybody can tell?
Captive mine ore goes to their own plant, and in merchant mining they have to sell it to
Yeah,
suppliers.
so that is where the thin silk deal. Because in merchant mining, even if they say high silica, high alumina, there could be a market for particularly this one sponge iron they make, or they're using cast iron. Obviously, people are ready to make use of that in higher distance. They can. But if you are purely a steel plant, the critical part will be all the three: silica, alumina, mainly iron, followed by these two. So to that extent, you put a cutoff and do that and declare your resource. So this could change depending upon the end use. So that is why it is given depending upon the end use you classify this. So then the forest is a common one. This comes under the feasibility level. So you have got an economic sense, it makes everything, but you don't have forest permission to clear it off. So then your problem is there. Because economically it's fine, geologically it meets your requirement, but you cannot do that. Go to the next one. हाँ उसी को एक एक डाल के दो। अरे एक एक डाल के देने के लिए बोलो, that is simple. उसी को बोलो. Go to the next one. Yeah. Now, so as I told you, please remember this EFG. It's all in alphabet. Economic, feasibility, geological. Okay. Next. Go to. So geological assessment 4 course detail 1, 2, 3, 4. I think people are clear about this. Yes. Next. Feasibility is 1, 2, 3. So you see the arrow which is going from bottom to top. So as you go up, your confidence level is increasing. That is a very important thing you know. From the bottom to the top level. Wait, go to the next one. Yeah. Economic also same. 3, 2, 1. Okay, next. So I will not get into this because it has got lot of wording for this PPT is already circulated. So go to the next. So now go back actually one step backwards. 3, 3, 4. Anybody can tell what is this 3, 3, 4? Anybody from here? No. I am talking code 3, 3, 4 means what? Convert the 3 into what? 3. What do you mean by 3, 3, 4? I am not asking literal meaning because earlier I explained you the code. What does it apply? First is first digit, second digit, third digit. What are the axes they are talking about here?
Geological and physical.
1 minute. Yeah.
The third axis of the feasibility, third axis of
No. 3, 3, 4. What is the first 3 denotes?
stages.
Stages of resource. Then take. So 3, 3, 4. Let me again I'm asking you. First 3 denote to which axis?
Economic,
Okay. Second 3 denotes to.
feasibility,
Then the third digit. Geology. No, EFG. That is where wherever this 3 code appears, please put your alphabet EFG. Economic, feasibility, geology. Now come to the next level. Under E, economic, when it says 3, you look at that. Intrinsic will be there. Then at feasibility, the coding will be there. Then 4. Now here, what is the 4 here? Mechanism. So then we go to the next level. Next level. So now you see that GSI is maintaining that, as I told you, 3, 3 will remain because they have been further exploration. They said taking it to the indicated mineral resource, that is G2 category. Its categorization is indicated, but extent of exploration done is G2 level. Here, okay. Now comes G1. So G4, G3, G3 is for mechanisms. Indicate import resource, then you got indicated, then measured resource. Go to the next one. Inferred. So the word tree. So this inferred terminology, indicator terminology are measured or here it's called proven it comes. All are related to geology only. Last axis. Go to the next one. Measure. As I told you. So it has gone to 1. Okay? Now we can look the geological axis changes. E and F also has gone up from 3 to 2, next level. That's where the pre-feasibility the wording is now. So what are the things covered under that is defined. Now you got it under feasibility 211. So you have reached a stage of G of 1 category. Even feasibility also done, that's why it's 1. Economic wise it's still in the pre, that is why it is 2 there. Next. So the important thing we should know is you have understood all the 3 axes are out. Focus on the G. And under for G, you have got 4, 3, 2, 1. What level of confidence, what is required to be done, that should be clear. And tomorrow, if anybody talks G3 level, it has been done, G2 level, it has been done. This is okay. So now we have to all are lot of terminologies. You have to read and understand because if you want to explain, it still doesn't make sense. But at least focus on the G part very clearly at your level. Same thing is getting repeated. Yeah. There are so many terminologies to go through that. This is important to know which are the categories which you can classify under UNSC and reserve. Even if it is 1 or even if it is geological axis, G2 level also can be, provided other 2 parameters are 1 and 2. For example, economic and feasibility should be next higher level, then you can call it. So, go back, just 1 minute. See, recognizes mineral resource, always 4, inferred is 3, indicated is 2, 1. Whereas other E and F axis remains the same as 3. Okay? Yes. Although we call it at international level, it is not at international level. We are still lagging there. So now it's clear what is G2, G1, G3, G4. वो खाने के बाद वो काफी काला है बालकृष्ण आफ्टर दैट वो एक्सेल शीट को लगा अभी नहीं 5 minutes we will have a break.